Hello and welcome back to Michael Project Solutions. I am Turnwait Otu Michael, and today I will walk you through how to run an independent sample t-test using SPSS. This test is used when you want to compare the means of two different groups. For example, males versus females, or employed versus unemployed. Make sure your SPSS file is open, and then you have your data set uploaded just the way you can see it appears here. So now, if you look at my data set, you can see residence, gender, and exam scores. Independent t-test, when you are running, it's expected you should have a continuous dependent variable, which we have in our exam score, and a categorical independent variables with two groups, which says you have in gender. Let's go to variable view. So you see, so these are variable view. If you look at this, you're going to see gender. Gender is divided into two groups, males, females. Then while the exam score here is continuous. Now let's go back. If you look, you see exam score is continuous. Gender is categorical. How do you run the independent t-test? Go to the top of the menu, click Analyze, scroll down to Compare Means and Proportion. If you're using the SPSS version 30, if you're using the previous version, you may see only Compare Means. Tick Compare Means. Then scroll down, you see Independent Sample t-test. Click Independent Sample t-test. Click. When you have done this, then you understand that we have done this. You will check and the variables. These are your variables. So our variable of interest is exam score. So, and it's continuous variable. You pick the exam score, put it on the test variable. This is our exam score. We put on the test variable box. And then the gender, which is the independent variables with two categories, male, females. You are going to pick gender, put under grouping. You can see there's enter groupings. When you have done that, always remember to define this group. You can see there are two question marks indicating here, and make sure that your independent variable, this gender, is in two groups. It can be employed, unemployed. It can be urban or rural areas, but it should be two groups. Now define groups. You click these groups because our gender was, we grouped the number one, which was male. We coded it 1, and then we coded females 2. Therefore, we are leaving it 1, 2. If you had coded your own, for example, yes or no, and you coded 0 and 1, you will have changed it to 0 and then here to 1, because we coded females 2, males 1. We are leaving it group 1, 1, group 2, 2. When you have done that, click continue. And then go to your options. Click options and leave it the way it is at default. Don't touch anything. Just click continue. When you have done that, come to OK. Click OK. Your results will display in the SPSS outputs. When these results are displayed as it is, the t-test results, you see that there are two specific tables in some previous SPSS version, but for this current one, you see there are three important variables, although still two are more important: the test score and the independent sample test table. The test table, group statistics table, and the independent sample test table. You see another table here, which is independent samples effect size. So we have three different tables here. The first table here is telling us the gender, males, females, number of cases, that is number of respondents, 970 males and females are 1018. Look at the mean here. The mean, we have 228.68 mean for males, and the mean, which is average for females, we have 29.88. The standard deviation, 9.898 and 9.606 for female. This is for standard error. Now come down. When you have run this, what usually determines your independent sample t-test table selection is what is called this Levene's test for equality of variance. Take note of this, very important. Levene's test for equality of variance. This Levene test of equality of variance has here the F statistics, and then which gives us 0.305, that is 0.305. What you need to take note that is very important in determining your selection of which of the column you have to choose from this exam score column. Look, this particular column has two rows. One of the rows is called equal variance assume, and the next one is called equal variance not assume. Take note of this, very important. You must choose one of these rows to report. Either you report the first row or you report the second row. Very important. What determines the selection of the first row, which is equal variance assume or equal variance not assume, is this significance level here. Take note of the significance level. If this significance level here, this particular one is less than 0.05, if it's less than 0.05 significant level, take the second row. Take the equal variance not assume. If it is more than 0.05, greater than 0.05, take the first row. Here it is greater than 0.05. You can see it's greater than 0.05. So we are going to report the first row. It simply means equal variance assumed, and it also means that it does not violate the variance principles or rules guiding the adoption of equal variance assumed. So this is appropriate. In a good note, again, it is appropriate and is a desire of statisticians to have equal variance assumed not statistically significant at this level, this very one. You know, you have another significant level here if you come from under two-sided p-value. This is different. The one that determines the selection of either the first row report or the second row report, just to repeat again, is this very significance level. So because it is, let me show you something, maybe you can be able to take it, maybe it helps you. Let me see. If you look at my table, this reflects here, look at it. So you can help to make decision. Independent sample test table. Look at the Levene test for equality of variance, which we have done now. Now, if significance greater than 0.05, use the first rule, equal variance assume. If significance less than 0.05, use the second rule, equal variance not assumed, which gives the Wells t-test. We'll talk about this. Let's continue. Just for you to take notes of it. Okay? Now, we are now going back to our reports. So this is our t-test here, statistics. So because we are taking the first row, which is this, we are going to focus on this. And then after selecting the first row, this is a degree of freedom, DF. And then you come here and focus on the two-sided p-value, significance level. On this column, there are two significance levels here, one-sided p and two-sided p. Take the two-sided p, that is two-sided significant level. Here you see that if this significant level is less than 0.05, you know that there is a significant difference between the two groups. But if it's greater than 0.05, it simply means there is no significant difference between the two groups tested. No significant difference between male and females. That's what I mean. But in this context, there is a significant difference between the males and the female students on their exam scores. So, because it's less than 0.05, the main difference is minus 1.19. Its standard deviation is here, and then this here confidence interval, which also indicates here. Maybe let's move further so you can see. This is your confidence interval. So you report the first row because this place is greater than, because the significant level on that Levene test for equality of variance is greater than 0.05, meaning equal variance assumed. And this is the independent sample effect sizes. This independent sample effect size tells us that if you look at, you only mainly consider this Cohen's d test. And if you look at it well, what you're going to consider more is this point estimate. It tells us to what extent the effect is, the effect whether large or small. But if you look at this, you're going to see you have less effects. Minus 0. Invisible 0, that's what I call 0. Minus 0.123. So since we have minus 0.123, it's less effect. Like verse size. We'll talk about this. Let me display to you how you can report this in your thesis or reports if you are to do that. So now let's see. Let me look at this. How to interpret reports, results, or reports your results in thesis or reports. You can adopt this one as sample. Let's see how it is. Look at this. An independent sample t-test was conducted to compare exam scores between males and female students. There was a statistical significant difference in scores with female students, mean, that is mean, look at this, female students, female students, male, mean, look at the mean, 29.88. Female student mean 29.88 on this SPSS column, 29.88. Standard deviation, 9.61. Approximation. Scoring higher than male students. Male student mean, the M stand for mean, 28.68. Look at this, 28.68. Standard deviation, 9.90 based on approximation. T value, which is what you have here. Let's see if I can be able to reduce this a bit to one corner so that you may see. Now, so that maybe you'll be able to see to help in your reporting in your thesis or exams. Now, look at this. So if you have here the t-test, T statistics, which is T statistics here, the T, number of cases, Is this 1986 is where it is? Number of cases. You must also ensure you have degree of freedom here. On the T bracket open degree of freedom, which is 1986 degree of freedom equals to minus 2.74 minus 2.74, which equals to this T value minus 2.7 approximation 4. Remember, T bracket open, T equals to, that is why it's called this number, minus 2.74 stand for the T. Why this bracket inside is degree of freedom, which is degree of freedom. So, put your comma, P equals to 0.006, invisible 0 here. That is 0.006. P equals to 0.006. Here we are talking about this one, two-sided p-value under the significance. So what does this mean? This gives us that, tells us that Levene test indicates no violation of the assumption of equal variance. P-value equals to 0.581. P-value equals to 0.581, which is this. Come back to the SPSS table, you see this column. The effect size was small. Cohen D equals to minus 0.123, which is this. Equal n, this last vet here, co-n minus the invisible 0 here, 0.123. So now let's go back to the report suggesting a modest practical difference between groups. So this is how you interpret or report your results in thesis and reports. We truly value your feedback, and please drop your thoughts and questions in the comment box below. Thank you for subscribing.